In this video, we will be discussing simplifying fractions and then multiplying and dividing fractions. So a fraction is a way to write a part of a whole. So if you don't have a whole item, maybe you have one out of two pieces, you could say that you have 1/2 of something. That's what a fraction represents. So the denominator is the number of equal parts the whole has been divided into, and the numerator indicates how many parts you're including. Equivalent fractions are fractions that have the same value. So you're going to use equivalent fractions a lot. Normally you'll be trying to reduce fractions, but sometimes, for example, when you're trying to add or subtract fractions and you have to have a common denominator, you'll be scaling fractions up and finding an equivalent fraction that has larger numbers so that you can add or subtract it to another fraction. So this first part, what we want to do is find equivalent fractions for each of the fractions listed. In this case, we have 1/2. That's in lowest terms, but we can find equivalent fractions by multiplying or dividing the numerator and the denominator by the same factor. So for example, for 1/2, if I wanted to multiply both of these by something, I could pick any number. Let's say I multiply by 2 over 2. Notice if I multiply by 2 over 2, 2 over 2, or 2 divided by 2 is 1. So I'm not changing the value of the fraction. If I multiply by 2 over 2, 1 times 2, I multiply straight across, is 2. And 2 times 2 is 4. So just to draw a quick picture, if I have a circle and I cut it in half, so 1/2 means I have one piece out of 2. So there are 2 pieces and I have one piece. That would look like this. Now let's say I have the same whole, so the same circle, but instead of having 2 pieces, the denominator says I have 4 pieces. But I have 2 of those 4 pieces. So here's one piece and here's another piece. Notice that I've colored in the same amount of the circle. I've colored in 1 out of 2 pieces or 2 out of 4 pieces, but either way, it's half of the circle. So they're the same value. They mean the same thing. So that's why they're equivalent fractions. So for the 1/2, I can scale it up by 2, 3, 4, 5. It doesn't matter what number I use. I'm multiplying the top and the bottom by the same number. So 1 times 4 is 4. 2 times 4 is 8. 4/8 is also equivalent to 1/2. And then I could do, it doesn't matter what number you pick. So I could do 10. 1 times 10 is 10. 2 times 10 is 20. 10 over 20 is also an equivalent fraction. So 2/4, 4/8, 10/20, 1/2, those all mean the same thing. They have the same value. So I can do the same thing with 2/5. So let's say I pick 2. That will give me 4 over 10. Maybe I also pick, that looks like a 6. Let's see, it should be a 5. Okay, let's say I also pick 3. And I pick 4. So 2 times 3 is 6. 5 times 3 is 15. 2 times 4 is 8. 5 times 4 is 20. So 4/10, 6/15, 8/20, 2/5, those all are equivalent fractions. They all represent the same part of the whole. So in the next part, 3 through 6, we're going to be going the opposite way. We're going to be simplifying, which means we're going to try to get it in lowest terms, which means we're going to divide out as many like factors as we can. We want the numbers to be as small as possible. This only works to keep it an equivalent fraction if you divide out the same thing from the numerator and the denominator. So let's look at number 3. 32 over 56. Maybe you don't know what goes into both of those, but you notice they're both even. So maybe the first thing you say is, well, I can divide a 2 out of both numbers because 32 is even and so is 56. So if we do that, 32 divided by 2 is 16, and 56 divided by 2 is 28. Now, notice the numbers are still both even. Well, that means I can divide out another 2. So that's going to give me 16 divided by 2 is 8. 28 divided by 2 is 14. Okay, notice they're both still even. So I can again divide out a 2. So still bringing the negative along. 8 divided by 2 is 4. 14 divided by 2 is 7. So now I have 4 over 7. Notice that 7 is a prime number. The only factors of 7 are 1 and 7. Well, I can't do anything with that regarding the 4. So this is in lowest terms. I cannot divide out any number from both 4 and 7 evenly. So this is in lowest terms. Notice I had to keep going until I couldn't possibly divide both of the numbers by the same whole number. Since we had to do 3 steps, this means I could have actually taken a bigger number out in the beginning. So negative 32 over 56, both of these numbers are actually divisible by 8. So if I would have noticed that from the very beginning, 32 divided by 8 is 4, and 56 divided by 8 is 7, I would have arrived at my simplest form after one division, instead of having to do 3. So it doesn't matter which avenue you take, as long as you make sure that you get it to the final or simplest form at the end. So it may take you one division, it may take you several iterations of division, but keep going until it's in simplest form. Okay, so let's look at number 4, 12 and 36. There are several things that you could divide by. Maybe you see that the largest is 12. That would be great because that'll take you right to the answer. But let's say you didn't. Let's say you thought 3. So if we divide both the top and the bottom by 3, we would get 4 over 12. And now hopefully you would see that, well, 4 and 12 are both even, so you could at least take out a 2. But maybe you notice that you could divide them both by 4. If you divide them both by 4, you'll get, oops, not 3. 4 divided by 4 is 1, and 12 divided by 4 is 3, so you will get 1/3. If in the first step you notice they're both divisible by 12, and you did that, you would get 1/3 right away. All right, number 5, 210 over 385. So since both numbers end in a 0 or a 5, I know that both of these are divisible by 5. So rather than trying to think real hard and find a bigger number that goes into both of those, I'm just going to go ahead and do the 5. So 210 divided by 5 is 42. And then 385 divided by 5 is 77. And so now I'm looking at both of these numbers. 77, the only options I have there are 7 and 11. So this is only 7 and 11. Well, 42 is not divisible by 11, but it is divisible by 7. If I broke it down, it would be 7 times 6. So that means I can divide both of these numbers by 7. So that's what I will do. So 42 divided by 7 is 6, and 77 divided by 7 is 11. That is in lowest terms, so I'm done. Number 6, 14 and 27. So I can break down 14 into 2 times 7, and that's my only option. 27 could be 3 times 9, and that's the only option. Notice I don't have any factors in common. The top is 2 and 7, the bottom is 3 and 9. They don't have anything in common. So I can't divide 14 and 27 by the same factor. That means that this is already in simplest form. So this one's kind of a trick. So this is already in simplest form. Okay, the next part of this is going to be multiplication section. So when you multiply fractions, you have two options. One option is to multiply straight across and then reduce the fraction. So option 1 is to just multiply straight across. So 2 times 21 is 42. And 7 times 22 is 154. But then once you do that, you have to reduce. So you're going to have to figure out what you could divide both of these by. So you could divide them both by 2. So 42 divided by 2 is 21. And 154 divided by 2 is 77. And then you would need to notice that both of these are divisible by 7. And so you would get 3 over 11, which is in lowest terms. So that's one option. That's one way to do it. I would suggest trying another way. So you can cross simplify. So rather than multiplying and simplifying second, you can simplify the factors now. That way when you multiply, your numbers will already be smaller and it'll be much easier to reduce, or perhaps you won't even have to reduce at all. You can simplify any numerator with any denominator when you have multiplication of fractions like this. So if I'm looking at 2 and 22, so 2 is a factor that's in the numerator and 22 is a factor that's in the denominator. I can reduce that because both of them are evenly divisible by 2. So 2 divided by 2 is 1, and 22 divided by 2 is 11. Okay, now I'm going to look at the other factors. I have 7 and 21. Both of those are evenly divisible by 7. So 7 divided by 7 is 1, and 21 divided by 7 is 3. I have nothing else that's in common that I can divide out, so now I simply multiply across. So on the top, I have 1 times 3, so that'll give me 3. And on the bottom, I have 1 times 11, and that will give me 11. So my answer here is 3/11. Notice that it's in simplest form, and it's the same thing we got in the first option, from the first option. So let's look at number 8, 9, and 10. For the remaining examples, I'm going to use option 2. It's a good habit to have, kind of get in the habit of using this option, because later we will be dealing with rational expressions. You'll have fractions with variable expressions. You know, something that looks like I don't know, something like this. Doesn't that look terrible? So if you have something like this, you don't want to just multiply straight across. You want to simplify by crossing out like factors. That's going to make your life so much easier. So if you go ahead and kind of get the hang of the process now, when you just have numbers, it will be easier to apply that method to something nastier like what I just showed you. All right, so let's look at number 8. So number 8, I'm going to pick one numerator and one denominator that I see that have something in common. So I'm going to look at the 10, and I'm going to divide it or simplify it with a 15. So 10 and 15 can both be divided by 5. So 10 divided by 5 is 2, and 15 divided by 5 is 3. So now I am going to look at 8 and 28. So 8 and 28 can both be divided by, I believe, 4. So 8 divided by 4 is 2. 28 divided by 4, that's 7. Okay, so no other factors of the top can reduce with the bottom. So I'm going to multiply straight across. Notice that I had a positive 10 over 28 times a negative 8 over 15. So since I have a positive times a negative, my answer is going to be negative. 2 times 2 is 4. And on the bottom, I have 7 times 3, so that's 21. 4 and 21 cannot be reduced, so this is it. All right, number 9. We have 63. I'm going to look at 63 and 90. First, let's go ahead and notice that I have a negative times a negative. So if you want, you can remind yourself that your answer is going to be positive. Okay. So 63 and 90, those are both divisible by 9. So 63 divided by 9 is 7, and 90 divided by 9 is 10. And then I'm going to look at the 84 and the 44. So I'm thinking they're both divisible by 4. I don't know if there's a bigger number or not, but we'll try 4. So 44 divided by 4 is 11. 84 divided by 4 is 21. Now I'm going to keep looking. Notice that I have 7 in red on top and 21 in blue on the bottom. 7 and 21 can also be reduced. So you can use the numbers again and continue reducing if it's possible. So 7 and 21 are both divisible by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. Now there's nothing else that I can divide out. So I'm going to multiply straight across. So 1 times 11 on top and 3 times 10 on bottom. So I get 11 over 30 as my answer. And I don't have to have the positive sign. It was just there to remind myself it was positive. Okay, number 10, we have 4 times 3 tenths. Anytime you have a whole number, you can write it over 1. So this is the same as 4 over 1 times 3 tenths. Okay, so now I can try to reduce. So I'm going to look at 4 and 10. Those are both evenly divisible by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. It doesn't look like there's anything else I can do. So I'm going to multiply straight across. 2 times 3 is 6. 1 times 5 is 5. And that's it. Don't change to a mixed number. Go ahead and leave it as an improper fraction. And that's it for the multiplying. So the last thing we're going to look at, let's just make sure, yep, these are the last examples, are the division problems. So divide and simplify. Division, you're actually just going to change it to multiplication and use the multiplication rules. But in order to change to multiplication, you have to flip the second fraction. So you can use the KFC rule, or maybe you learned KCF. I learned KFC because it's like the chicken. It's easy to remember. So keep, flip, change. So this means you're going to keep the first fraction. Whoops. Okay, let me not write up so high. Let's move this down. All right, so keep the first fraction. Flip the second fraction. And change to multiplication. So let's see that in action. In number 11, I'm going to keep the first fraction the same. I'm going to flip the second fraction. So instead of being 7 over 4, it's going to be 4 over 7. And I'm going to change the division to multiplication. And now, since I've changed it to multiplication, I just do the same thing I did in the last 4 examples. I can cross reduce. So we have a 7 and a 7. Those are both evenly divisible by 7. So that would be a 1 and a 1. Nothing else is in common. So I'll multiply straight across, and I will get -4/9. Number 12, I'm going to keep the first fraction, flip the second fraction, change to multiplication. I can cross reduce. So notice the 5s are the same, so those are just going to cancel out. Those divide out to 1s. And the 6s are the same, so those are both evenly divisible by 6. So those cross out and become 1s. So all I have left is 1s. So 1 times 1 is 1. 1 times 1 is 1. 1 divided by itself is just 1. Number 13, we have 6/7. That stays the same. 12 over 1, I'm going to flip, so it'll be 1/12. Change division to multiplication, and then simplify. So I have the 6 and the 12. Those are both divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. Multiply straight across, and I get 1/14. And then our last example. 2 negatives will make a positive, so point that out first. First fraction stays the same. Flip the second fraction, change to multiplication, and then reduce. So 7 and 14 are both divisible by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. And then I have 18 and 27. Those are both divisible by 9. So 18 divided by 9 is 2. 27 divided by 9 is 3. Multiply straight across, and I will get 3/4.